Okay, so our next functional group is the aldehyde. So an aldehyde is an organic molecule where we have a carbonyl attached to at least one hydrogen. Our parent chain is going to be the longest carbon chain containing the carbonyl, and numbering is always going to begin with the carbonyl carbon. So position 1 will always be the carbonyl. And we're going to name aldehydes by taking the alkane name, dropping the E, and replacing it with al, A-L. Okay, so go ahead and pause this video and see if you can come up with IUPAC names for both of the aldehydes on this slide. Okay, let's see what you came up with. We'll start with the one at the top. So we'll begin by numbering our carbon chain. And remember, for aldehydes, we always start at the carbonyl carbon. So a 4-carbon alkane would be butane. And we're just going to drop the E and replace it with Al. So the final name for this molecule is butanal. Okay, so let's try this one at the bottom. So remember, we have to start numbering at the carbonyl carbon. And then here at our branch point, it doesn't matter which way we go because we have 3 carbons in either direction. So a 5-carbon alkane would be pentane. We're going to drop the E and replace it with al. And it looks like we have a 3-carbon substituent. So that would be a propyl group. And our propyl group is attached to position 2. So the final IUPAC name for this molecule is 2-propylpentanal. Okay, our next group is the ketone. So a ketone is going to be a carbonyl attached to 2 other carbon atoms. Our parent chain is going to be the longest carbon chain containing the carbonyl, and we're going to start numbering these at the end nearest the carbonyl. So our parent chain, we're going to take the alkane name, drop the E, and replace it with one, O-N-E. And unlike carboxylic acids or aldehydes where the carbonyl is always position 1, for a ketone, we have to give the position of the carbonyl unless there's only one option. And I'll show you more what I mean by that with the examples on this page. Okay, so go ahead and pause this video and see if you can come up with a name for these 2 ketones. Okay, so let's start with the one at the top right. We'll start by numbering our chain, and we're going to start at the end nearest the carbonyl. So we have 4 carbons, so a 4-carbon alkane would be butane. And we're going to drop the E and replace it with one, O-N-E. Okay, do we need to give a position for the carbonyl? So it's at position 2, but my question for you is there any other position the carbonyl could be on a 4-carbon ketone? So it can't be at positions 1 or 4 because then it wouldn't be a ketone, right? For it to meet the definition of a ketone, the carbonyl has to be attached directly to 2 other carbons, therefore it cannot be at one of the terminal carbons. So what if we move the carbonyl to position 3? Well, now we would just have to number our carbon chain in the opposite order, and the carbonyl is still position 2. So for a 3-carbon ketone or a 4-carbon ketone, position 2 is the only place the carbonyl can be. So if you tell me the name of this molecule is 2-butanone, you will get 100% credit, but you will also get 100% credit if you just say butanone. Okay, so let's see what you came up with this guy down here at the bottom. So we're going to start by numbering our parent chain, so the longest carbon chain containing the carbonyl. So our parent chain has 10 carbons, so a 10-carbon alkane would be decane. We're going to drop the E and replace it with one. But we still have to give the position for our carbonyl, and that's at position 2. And now let's see what kind of substituents we have. So to make this easy, we'll go ahead and number the carbons on each substituent. So this substituent at carbon 3 has 2 carbons. The substituent at carbon 4 also has 2 carbons. The substituent at carbon 5 only has 1. And the substituent at carbon 7 also has 2. So it looks like we have 3 ethyl groups and 1 methyl group. So remember, we're going to place our substituents in alphabetical order. So our ethyl groups will come first, and they're at positions 3, 4, and 7. So we have 3, 4, 7 triethyl. And then we have our methyl group at position 5. So 5 methyl. So that gives us a final IUPAC name of 3, 4, 7 triethyl, 5 methyl, 2 decanone.